Firstly, thank you very much for that lovely introduction, and SMI for giving me the chance to speak here. As you mentioned, I'm going to go talking about clean maritime within offshore renewable energy, but then looking slightly more specific at some of the examples of collaboration within clean maritime, and how I think that collaboration is probably one of the essentials in terms of getting to clean maritime in the most efficient way possible. So, firstly, before we talk about offshore renewables and where we want to go to, it's important to look at where we are at now. And this graph is probably not new to many of you, but it looks at the sort of fueling that's used by vessels in the global maritime sphere as it is. And the obvious standout is, of course, that by and large, it is all fossil fuels. So we talk about a lot of these clean maritime decarbonisation, but where we're at the moment is fossil fuels almost by and large across the sector. Now, where we need to go, I'd suggest the fuels I put up here might be slightly controversial, but happy to talk to them later on. We need to essentially convert all of this to battery electric, hydrogen, ammonia, and methanol. Some of you will see there's a few emissions in there. The government has very helpfully outlined plans that we're looking for absolute zero, so I've left off the likes of LNG, CNG in there. I've also left off HVO, although I do think that is going to be an important part of decarbonisation, looking towards 2050, and especially looking towards UK content. These e-fuels that we can create locally from our own offshore renewable content, I think is where we need to look going towards the future. So, one other thing to say on that graph, I guess, is the relative small section which is taken up by vessels in the offshore renewable sector. So I guess it's important to say why I think they do make up an important part and why we need to consider them very strongly in terms of UK content going forwards towards clean maritime and UK shipbuilding. So why could offshore wind and offshore renewables more widely be an important part of that clean maritime picture? The first thing to say is this is an industry built on decarbonisation. Stuart alluded to the fact that now there's a huge move towards offshore wind because it's cheap. It means we don't need to rely on foreign fossil fuels. But essentially, when this industry was set up, when it got all its support, it did so because of that opportunity to remove carbon emissions, to get rid of greenhouse gases. And that's very much a part of the industry today. It's why we saw those companies like the big Ørsted, RWE, Vattenfall sign up to this Operation Zero to say, actually, even though emissions from offshore wind are very low comparative to gas or coal, we want to go further. We want to make this a truly zero carbon way of producing electricity. And the maritime sector will be a big part of that, those vessels that go out to service the wind farms. Secondly, it's a huge growth industry. Even though it's a relatively smaller sector now, even with the UK's huge build-out we have of offshore wind, it's going to get a lot bigger. This map taken very quickly, the green, this is what we have already online in terms of offshore wind farms. The two blue colours are the pipeline capacity. That's what's coming on board, and it dwarfs what's already in the water. In fact, this map was a 2021 map. Already, it's out of date. You could add huge areas around Scotland, which were recently leased in the ScotWind. This means that vessel sector is going to be getting bigger. There's also going to be a huge demand for vessels. It's somewhere where UK content has an opportunity to bid in to produce these new vessels as the sector grows. Before I move on to that, I guess, this is the vessels side of things. This is why offshore renewables make such an important part in terms of the demand for vessels and why I think that clean vessels will be a part of that. But offshore renewables also take the other side. They can be the supply. They can supply that fuel, that energy needed for the vessels. Now, I've just taken a quick grab of the UK's energy sector for February. Now, admittedly, February was a very windy month, as everyone's well aware. But this just lays out where we got our electricity from. And you can see, as people point out quite regularly, you've got these high peaks of demand when everyone turns on their electric heater in the evening. And you've got some of that made up by wind, some of that made up by gas, some of that made up by nuclear. When the wind is low, obviously the gas goes up slightly. But when the wind is high and demand is low, we're very quickly getting to the point where our renewable capacity is actually going to outstrip what the national grid can take. Every owner-operator operating a wind farm is now looking towards their product not just being a supply of electricity for the grid, but also looking for new markets for their product. One of those new markets is definitely going to be e-fuels, and I guess that's why I put up those 4 fuels on the board earlier. Battery electric, or then you can use your electricity to create hydrogen. Take that hydrogen, you can potentially create green ammonia, green methanol. The offshore wind industry and the offshore renewable energies industry more widely is going to want to supply these fuels. So it's in its own interest to build this market. If it can show that vessels can operate on clean, zero-emissions fuels, it can lead the way for the whole sector and create a market for its product. The last point, I guess, is a specific one to do with the vessels that are used in the offshore wind industry. Here's just one here. We're looking at a small vessel, a CTV potentially. As it goes out to a buoy, moors up, it can not only pull out a mooring line, it can potentially pull out a charging cable. Or maybe in the future, it could bunker with hydrogen offshore. These sorts of technologies are going to very much change the way we think about range constraints in the maritime sector. And offshore wind, as the location for this electricity generation, is very much going to lead the way in this area. So this is the document that I don't need to introduce because Stuart introduced it earlier, but I can pick on just a couple of points to this. With the view of not getting a yellow card, I'll just go for some of the red ones. I guess, in terms of barriers to maritime decarbonisation, the big obvious one is that cost of fuel. At the moment, if you're lucky enough to operate out of a port that supplies HVO or hydrogen, you're very unlikely to get it at a cost that's comparable to MGO, HFO, whatever it is. But there's also the question about what that fuel might be. Existing port infrastructure, portside electrical power constraints, lack of clarity over future fuel pathways. We don't know what fuels all these vessels are going to be using, and that's a real barrier to shipbuilders who don't want to design a vessel that in 10 years' time they won't be able to bunker at their chosen port. So, I said at the start I was going to look at a couple of examples, and I think before I do that, again, a lot of you very aware of the vessels used in offshore wind, so I'm very quickly going to go over a couple of the O&M vessels that I'll talk to. Firstly, you've got a crew transfer there, a relatively small, still sort of 20 packs plus, but relatively small, relatively fast vessel capable of transferring technicians from the port to the wind farm and then transferring them between the wind turbines so that technicians can work on the operation and maintenance of the turbines. And secondly, we've got the larger SOVs. It's a much larger vessel which will travel out to the wind farm, potentially spend a couple of weeks in the wind farm. Accommodation for the technicians on board. They can stay, sleep, eat, and then move between the different turbines for longer periods. 2 vessels, not the only vessels used. There are lots of autonomous technologies coming through, but these are the ones we'll have a look at. And so we'll talk to, first off, this CTV. And we'll consider what sort of fuels a CTV might like to use. And we'll go back to those 4 fuels: electricity, hydrogen, ammonia, methanol. Now, as we said, the cost of these fuels is going to be hugely important, as any vessel operator will know. So we want to use it in the most efficient way possible. If we use electricity, we don't have very many losses. We can go straight from the power that comes from the wind turbine, charge up a battery. If we wish to use hydrogen, we've got to put it through an electrolyzer, slightly more losses along the way. Furthermore, ammonia, you get some more losses, and then methanol, further losses, and also you've got the consideration about where that CO2 comes from. But of course, it doesn't mean that's a straight win from battery electric, because on the other side of the coin is the range considerations. For a given size or weight, methanol has a lot more energy stored in it than battery electric or hydrogen. So if you need to go a long way without fueling up, methanol will take your fancy. So ideally, we want to use whatever the most efficient fuel we can in these CTVs. So we take battery electric and we look at that. Now, for a CTV that's relatively fast moving, you potentially can't go that far with the batteries in the hull. It means you're limited just to the near-to-shore wind farms and maybe only transiting between 2 or 3 turbines once you get there. But what you could do is actually install a charging point on your turbine. And this is one of the projects we're working on with the CMDC project. If, once I'm out in the field, I can charge from the turbine, suddenly from having to have the range to go from shore to the field, transit in the field and back. All I need is the range to get to the wind farm, plus obviously some redundancy. And this is one of the areas where I think collaboration is going to be so important. Previously, when we look at new technologies, we still look at collaboration. You need to know the battery manufacturer, the vessel designer, the vessel operator. They all need to work together. But now, if we're looking at a new operational profile, we also need to consider how are we going to connect that CTV so it can operate not just in this wind farm, but in other wind farms across the world. We need to look at someone to install this charging infrastructure. If we're going to do that, we also need to work in collaboration with the wind turbine manufacturer, the owner operator of the wind farm. We're no longer looking at just a simple piece of technology we can put into a vessel. We're looking at the whole ecosystem, right from power generation, fueling, right through to the vessel. But if we do that, that suddenly means lots more wind farms are capable of being reached by battery electric. Now, this isn't a plug, by the way, for battery electric vessels. The same thing could very potentially be possible with hydrogen fueling. If we have hydrogen fueling out in the field, then we can go even further, likewise ammonia and methanol. We need to consider not just changing the technology for our current operational profiles, but considering the whole operational profiles. Just to take that example one step further, this is an Artemis vessel. Now, Artemis Racing, very famous for their sort of round-the-world yachts. They develop a sort of a foiling technology there. The vessel comes out of the water. Now, if you're racing sailing yachts, you get rid of that hydrodynamic drag, you can go a lot faster. There's a difference between winning and losing. Actually, if we transfer that technology into the offshore wind sector, suddenly that drag means a battery electric vessel can go that bit further. You brought in another technology, and you brought more wind farms within the capability of zero emissions fuels. And it's only by bringing all these partners together you can really see what the best option is. We'll take another example. We'll look at that SOV that I brought up earlier. I'm aware later on, I think someone from Bibby is speaking, so I won't talk too much to this, but Bibby Wavemaster Zero C is a project to look at the potential fuels which could fuel this SOV. And it's looking at it from the other way. It's saying, we've got this SOV. If we want to be ready for the future, what do we need to fuel it with? Because as all of you know, these vessels are going to be in the water for 20, 25 years, and in 2040, 2050, no one expects fossil fuels to be the predominant vessel fuel of the future. So we've got to consider not just the technical details, which Bibby have been working with a number of partners with, but we've got to consider the wider industry to ensure that this doesn't become a stranded asset with nowhere to fuel. And on that note, ORE Catapult worked with a number in the industry, not just looking at ports who will be fueling these vessels, but also looking at competitors. Because you'll need to know what your competitor's using so that you can make sure the fuels you need in the future are available there. Because the alternative is you don't move towards zero emissions vessels, and then in 10, 20 years' time, as Stuart alluded to, those owner-operators aren't going to be procuring fossil fuel vessels, so you're equally left with an asset that can't get you any tenders. So I guess to bring together some of the things I've been saying, we need to make sure the whole ecosystem is there. We need to make sure all players come together. That's going to be partially industry, it's going to be partially the regulators, the class societies. Everyone's there to make sure we bring decarbonisation in the most efficient manner possible. Now, I have to admit, this is a shameless plug to that Grimsby project mentioned earlier. So we're bringing that potential offshore charging, offshore bunkering, alongside the fuels within the port, but also bringing really anyone who has an interest in maritime decarbonisation to the party. And I really, if you haven't come across this project before, please find me later. I can tell you about it. If you want to be part of it, please do. And we can actually make Grimsby a decarbonised port, not for the sake of Grimsby, but for the sake of the wider maritime industry. Some of those ports you'll be hearing about later during the day, looking to put in the demonstration facilities so that we can share learning and make it easier for everyone across the industry. So I think on that note, to avoid getting a yellow card, I guess I'm going to move over just to the last quote. And I picked this quote not because I think it's a brilliant quote. It's a good quote, but it's not brilliant. The offshore wind sector deal was a deal signed by the industry, as the name suggests, and it had wide support from government and industry. And one of the things it set out was this. The sector has set a target of 60% lifetime UK content in domestic productions. That's right across the offshore wind sector. And that's obviously a brilliant thing. People in the UK don't just want sort of clean, secure energy. they also want the jobs that can bring with them. But I guess implicit in this is 60% UK content, there's going to be 40% overseas content. That's not a problem. That's obviously world-leading content. It's obviously the cutting-edge stuff which can bring over here. But if we're going to get the best of this investment we put into offshore renewables, part of this 60% is going to have to be UK world-leading content. And I really think that the maritime sector, and specifically the high-technology area of clean maritime, is going to be that leading part of UK technology that can not only make up a 60% chunk of domestic vessels, but they can actually follow these wind farms as they're built on the east coast of the States, in Taiwan, right across the world, and can actually be part of the export picture as well, so we can get as much benefit to this as possible. Not just high-tech vessels, but as the shipbuilding strategy suggested earlier, all the technology that comes with cleaning up maritime. So on that one there, I'd invite anyone who has any interest in clean maritime to consider the offshore wind sector as one of those first movers to prove technology and to build that expertise to export across the world. And I'll leave on that one. Thank you.